are going to be wrapping up what we started yesterday with our complex numbers, particularly our complex numbers in polar forms. Just as a bit of a reminder of where we left off, we had our formula for what happens when we multiply various complex numbers in their polar form, as well as divide. That ended up being very, very convenient, where if I take the product of two complex numbers, we'll say Z1 is R1 CIS of theta 1, and our second is R2 CIS of theta 2, then we can take their product by simply multiplying the magnitudes together and adding the thetas. Likewise, we could do something very, very similar with division, where if we were dividing two complex numbers, rather than going through that whole very arduous process that we learned way back in Unit 2, we can instead divide our magnitudes and subtract our angles, which gave us a very, very kind of convenient way to go about evaluating some of what we had. What we're going to be doing today is an application of these kind of various properties of, in particular, multiplication. What we're going to be looking at today is what happens when we raise a complex number to certain powers. So in particular, let's say that our z is defined as being r CIS of theta. My question is, using our kind of product rule here, what we observe from product, how could I figure out, maybe rewriting in terms of multiplication, how could I figure out what z squared is going to look like? So how could I rewrite z squared as two complex numbers being multiplied together? I have confidence that we can answer this one. How can I write something squared as a product? Yeah, it's just z times z. Now we know that the product of two complex numbers, we multiply the r's, we add the thetas. This is going to be r times r, CIS of theta plus theta. Well, r times r is just going to be r squared. CIS of theta plus theta is going to be 2 theta. Okay. What if we were to raise z to the power of 3? How could I rewrite this as the product of two complex numbers that I know? Z squared times z. Well, we know that z squared is r squared times r in this case, that magnitudes multiplied together, CIS of the thetas being added together. We get that this is r cubed CIS of 3 theta. So what's the pattern here? What is z to the power of 10 going to be equal to? So it's z to the 9th times z, which we could do it like recursively, but we could also, I think like Kevin was suggesting here, jump to the end, r to the power of 10, CIS of what? 10 theta. And extrapolating from there, if I take a generic power, z to the power of n, what is this going to be equal to? Exactly. R to the n CIS of n theta. We didn't really do powers of complex numbers. Really, it's just that multiplication process over and over again. But here we can see, again, something that would originally be very, very quite tricky becomes almost laughably easy when we are in this polar form. Now, this so far is like how it functions as a proof of this is not sufficient to show that this is true for all values of n. This would only really be something that we could say is true for those whole number values of n. And then I'm just going to ask that you trust me, or maybe you could look up a proof on your own time if you wanted to. It works for all values of n here. And we're going to use that fact kind of at the end of today in order to work out a couple of interesting problems. But just kind of noting that, in fact, this is just true for all values of n. No matter what power we are raising this to, positive, negative, fraction, whatever, this is going to be true. This is known as DeMoivre's theorem, which is that if we have z equal to r CIS of theta, then z to the power of n is r to the n CIS of n theta. Just kind of a quick application of how we do the products of these polar form complex numbers. So for instance, taking a look at example 4 here, we have some kind of complex number already in polar form. That's fairly convenient, raised to the power of 3. So what in this case for A is our value of R? What is our value of theta? R is 3 and theta is pi over 9. Exactly. This is the same as 3 CIS of pi over 9. Cosine plus I sine is what CIS means. And we are taking this value of z, we are raising it to the power of 3. What am I going to do with r? What am I going to do with theta to raise this to the power of 3? What do I do with r? Cube it. And what do I do with theta? Multiply it by 3. This is just going to be 3 cubed CIS of 3 times pi over 9, or 27 CIS of pi over 3. Yes. No. Pi over 3. 3 times pi over 9 is pi over 3. All right. Questions with our kind of base case DeMoivre's theorem? All right, take a stab at example B. Don't do more work than you need to. We already know what 3 plus 3i is in polar form. We did that for example 2 yesterday. So you already should know what r is. You should already know what theta is. You just use that. We are taking that z. We are raising it to the power of 4. I mean, you could, if you wanted to, find what r is, find what theta is again, but why do that one? We already did that one yesterday. So we found that yesterday. So that was this was our theta. And then this was our log. So that's this way. That was what we did for part A here. So this is how do you just raise it to the power four? You don't need to simplify it. Power 4. But 3 to the power 4 is 81. And root 2 to the power 4 is just 4. So 81 times 4. 320. What are we doing again? Oh, you're doing 18 times 18? 324.
Probably get 1,070.
It's like I'm already up there. My hair is literally the same
Well, this is your R, this is your theta. What's our value of n? Well, how are we doing?
I used to think it was
So what do we do with R? What do we do with theta? 3 to the 4th.
Actually, no, I didn't. I think I like knew that. But I still took pictures.
so common, I tried and I was so ugly. It would have been so
So this looks good for the new R. And then what do we do to the raise R to that power? This is there's 3 to the power 4 is 81, and then root 2 to the power 4 is
I never wear mine. I get no. It's just kind of pointless.
Simple math. I think I had to math. I think I've done math so much.
Sweat out of the shower. I don't want to put on a fur. And it just sticks to me.
I think this channel is burning my brain all the time. I can't do simple math anymore.
But it's just kind of like.
I used to do this
See,
in
that's,
my head.
see, it's because I don't make you
If
simplify.
I have to.
Yeah. It's because I allow us to be
I
lazy.
still get 1,000. I need to start writing my retainers.
Mine.
Are they?
Mine are.
Is it bad? I don't wear my retainer for a while. I get a gap in between the middle of my.
All right. So what was our complex number in its polar form? Remind me. What was our complex number in its polar form? What's R? What's theta? So 3 root 2 or the square root of 18. Either way is fine. CIS of pi over 4. What do I do to R? What do I do to theta? Multiply theta by 4 and exponentiate or raise 3 root 2 to the power of 4 and multiply theta by 4. I get 3 root 2 to the power of 4. 3 to the power of 4 is going to be 81. Root 2 to the power of 4 is just 4. And then 81 times 4 is going to be 324. CIS. 4 times pi over 4 is going to be pi. If we wanted to, we could evaluate this one pretty easily. CIS of pi, the x component is going to be -1. The y component is going to be 0. So the real component would be -1, y component would be 0i. This is going to be the same as -324, but I do not require you to convert to the rectangular form, so we are perfectly happy with just what we have here. 324, CIS of pi. All right, questions with this kind of initial application of DeMoivre's theorem? All right, we are going to be using DeMoivre's theorem to deal with something that actually otherwise would be fairly difficult to handle, and otherwise would not be particularly readily obvious how we approach. So we're going to be using DeMoivre's theorem to figure out roots of various complex numbers. Looking at 5a, we are trying to figure out the cube roots of 8. Like, wait a minute, we know what the cube root of 8 is. For instance, if we consider the equation that x cubed is equal to 8, how would we normally go about solving this? What would we do? Take the cube root of both sides, and what do we get for x? X is equal to 2. And so there's one cube root, and it's just 2, isn't it? Except, let's reconfigure this ever so slightly to get it into a form that we saw way back in Unit 2. If I subtract 8 from both sides, then this statement should be equivalent to saying that x cubed minus 8 is equal to 0. What we have on the left-hand side here is a polynomial. So thinking back to Unit 2, what degree is this polynomial? And by that degree, how many zeros would we expect it to have? It is a third-degree polynomial, and therefore we would expect to have 3 zeros. 2 turning points, 3 zeros. All right, so we suspect 3 zeros, but we only found 1 from taking the cube root of both sides. The question is, where are the other 2 zeros? Possibly this is a case where we have multiplicity, right? Maybe this is a situation where all 3 of those zeros are happening at 2. If that is the case, then we should be able to write this polynomial x cubed minus 8 as x minus 2 times x minus 2 times x minus 2. But if you try multiplying that out, you're not going to get x cubed minus 8. You're not going to get that is what that polynomial is. So 2 here actually does not have a multiplicity of 3. And so we are missing 2 solutions to this equation. We are going to use DeMoivre's theorem in order to figure out what the other 2 solutions are that we are missing for this particular polynomial. So we're going to use it to figure out what are the other 2 complex zeros here that we would otherwise be missing. All right, first and foremost, in order to use DeMoivre's, we need to take our kind of thing, our number that we are considering. In this case, we're thinking about 8. And we need to rewrite 8 as a complex number. So how can I write 8 in the form of a plus bi? What is going to be the value of a? What is going to be the value of b? Yeah, this is going to be 8 plus 0i. Now, in order to use DeMoivre's, what form do I need to be in? I need to be in my polar form. I need my RCIS of theta in order to be able to do that. How do I find R? What's my equation for finding R? Yeah, this is the square root of x squared plus y squared, or a squared plus b squared. However you want to do it, it is 8 squared plus 0 squared. The R value that I get is 8. Okay, good. The absolute value of 8 is in fact 8. It's nice that that is still working. And then what equations can I set up in order to figure out theta? Perfect. Perfect. So what is the value of theta? That is giving me an x value of 1 and a y value of 0 on the unit circle. What did we say? I like that answer. We're going to come back to that. So 2 pi is actually correct, but the smallest theta, positive theta that we could use, 0 would be what I would start with. But we are actually going to put a pin in Katie's answer, which is that 2 pi would also work as a good theta here. All right, so we can rewrite 8. This z is now equal to 8 CIS of 0. If I want to take the cube root of this complex number, taking the cube root is the same as doing what with regard to the power? Z to the what? Cube root is what power? Is it the third? Cubed would be the third power. The cubed root is going to be the 1/3 power. So raising our complex number to the power of 1/3, we get that this should be 8 to the 1/3, CIS of 1/3 times 0. This is 2 CIS of 0, which cosine of 0 is 1. So the real component here will be 2. And I sine of 0 is going to be 0i. So the imaginary component is 0. This is just equal to 2, which is what we found up here already. Okay, we've learned nothing. We already knew that 2 was going to be one of our solutions. We're still missing 2 solutions here. And so what we're going to need to do is find alternative ways to write 8 CIS of 0 so that we can keep applying DeMoivre's theorem and see, will that net us different solutions? For instance, I can't really change the value of R. If I change the value of R, then we're talking about a whole different number. If I change the magnitude, it's going to be completely different. But what's maybe another way, coming back to Katie's idea here, that I could write 8 CIS of 0 using a different theta? 8 CIS of 2 pi. Should be equivalent. It should be the same value. Right? That should also be 8. All right, let's use DeMoivre's theorem here. This is z to the 1/3, which is equal to 8 to the 1/3 CIS of 1/3 times 2 pi, which is 2 CIS of 2 pi over 3. That is a new solution. We didn't have that one before. How many solutions were we anticipating? We were anticipating up to 3. So let's maybe figure out another way that we can do this exact same thing. What's another way that I could write 8 CIS of 0 or 8 CIS of 2 pi? 8 CIS of 4 pi, I think, is a great one. We're just going to add 2 pi. We're going to find coterminal angles adding 2 pi over and over and over again. This will get us z to the 1/3, or we're taking z to the 1/3. This is 8 to the 1/3 CIS of 1/3 times 4 pi. I get that this is 2 CIS of 4 pi over 3. Again, a brand new solution. And these are our 3 solutions. Our 3 cube roots. We could write these in rectangular. It's not too bad. Cosine of 2 pi over 3 is going to be -1/2. 2 times -1/2 is -1. So this is, we got 2. We got -1. And then sine of 2 pi over 3 is √3 over 2. Times 2 would be √3. The sine component is the imaginary component, so like √3 times I. And then in quadrant 4, we'll get the same value of x, same value of y, but now both will be negative. So -1 minus √3 times I. But also, you're totally fine to just write this as like 2 CIS of 0, 2 CIS of 2 pi over 3, and 2 CIS of 4 pi over 3. That's also totally fine. All right, questions here with our using DeMoivre's in order to find roots. Yeah, Danny.
I didn't get that definition.
For the DeMoivre's?
Yeah.
Probably. That's fair. Yeah, Tessa. Yeah. I have a question. And that is, we kind of stopped at 0, 2 pi, 4 pi because we were happy with the number of solutions that we found. Is there anything stopping us from doing like 6 pi, 8 pi, 10 pi, 12 pi, so on? No. Certainly we could try this, right? If we did 8 CIS of 6 pi would be the next one. We can see what happens when we do z to the 1/3. This would be 8 to the 1/3 CIS of 1/3 times 6 pi, which would be equal to 2 CIS of 2 pi, which looks like a brand new solution. But in fact, is it a brand new solution? No, it's equivalent to which of these 3? It's equivalent to the first one. And if we were to try 8 pi, we would get something that's equivalent to the second one. And if we were to try 10 pi, we would get something that's equivalent to the third one. So it's not that we can't keep going. It's that if we keep going, we're just going to get repeating solutions. And so we can stop once we are happy with having our third solution. If we were looking for a fifth root, how many solutions would we expect to get? We'd expect 5, so we would need to add 2 pi to our theta 4 times in order to set those up. If we were looking at a square root, how many solutions would we be expecting? 2, so we would only need theta and then 1 coterminal angle with that theta plus 2 pi just that once, and then we should be good to go. Take a stab at part B here, which is finding the square roots of I. So my advice would be figure out what your A is, figure out what your B is, what is the real component, what is the imaginary component, what are the coefficients thereof. Find R, find theta, and then you're using a coterminal angle with theta, figuring out what those roots are going to be. That looks good. Very, very nice. Square root of 1 is just 1. R. Square root of -1.
No, I think I did the month. It's just for the guys.
You should talk to him.
Yeah, we're expecting it. So I squared is negative.
Everyone happens, you don't talk.
No, I squared is -1. But we're not looking for I squared.
Like,
We're
just
looking
not
for square
saying.
root
But I'm
of
not
I.
looking.
Did he say that he was gonna come talk to you?
So you're gonna need to use the pause. So thinking, how can I rewrite I in terms of R and theta? What's
Okay,
the
well, I'm gonna be all
value
sweaty and
of
gross. So
A
I'm not
and B here?
I'm gonna look probably my worst.
Well, B is
Sure,
what?
determiner.
B is the coefficient in front of I, which is wait, 1. So A is 0 for your C. B is
Wait,
1
zero?
times I. That value of B is 1.
Yeah.
I is just the direction. I just tell you that you go 1 times.
Are you all eating again?
Stay even.
So A is 0, B is 1, and then you're figuring out R, and then you're figuring out theta, and then you're applying the square root.
I can't decide what one I like.
Okay,
That's
this is
fine.
good. So, what is the, ooh, actually, a couple of things here. So what is the real component? So like here, we had 8 as our real component, and we had 0, 0. What is our real component? Do we have a real component? So 0 would be our A, and what would our
Now he turned on his location because I haven't like said anything because he wants to.
B would be, what's, how many I's?
It's ridiculous. Like, I
A
like,
and 1i, so a would be 0 plus 1i. B would be 1. Yeah, and that'll all help fix the trig.
Yeah, that makes sense. So then we plug it in.
Yes. So. Is the value of
It's you extremely close to your neighbor.
I? Is I ever involved in our calculation? So what is that value?
That doesn't
Now let's go over
Stop.
So the 1 is the hour value.
Okay.
Okay. Taking into consideration because we're gonna have some 1. Z is fate, it's the imaginary number or the complex number that we're taking. Well, it's the same thing. I'm asking you to take 8 plus 0i and raise it to 1/3. If I said z equals 3 CIS of 5/9, find z equal, I'm asking you to do the exact same thing.
Well, I can't have some. I don't know. I don't know how you can tell, but I'm pretty sure.
What's the square root of 1? 1. So, yeah, it's just 1. So what is the value of theta that gives us an x value of 1 and y, or an x value of 0 and y value? And then you need, and then 1 coterminal. Yes. Zero, yeah. 0 plus 1. Your value of A would be 1. Or sorry, your value of A would be 0.
Wait for you.
Staring at me, and it was like my 10 seconds ran out. No, she's like, and I could just go lower and lower. Still on top.
You're adding 2 pi at the bottom.
Okay, let's go over what we found. So one of the tricky things with I was figuring out the value of A and the value of B. How can I write I in terms of A plus BI? What is A? What is B? 0 plus 1 I. A is 0, B is 1, R is going to be the square root of 0 squared plus 1 squared. R is just equal to 1. And so the two equations that we get are 0 over 1 for cosine of theta and 1 over 1 for sine of theta. What is the theta that gives us an x value of 0 and a y value of positive 1? Pi over 2. Very good. What is a coterminal angle, or what is kind of the first coterminal angle with pi over 2? 5 pi over 2. Very good. So the two values of z that we are going to be working with are z, and you could think of this as 1 CIS of pi over 2, and z is equal to 1 CIS of 5 pi over 2. What power are we raising this to? Z to the 1/2, which is going to equal 1 to the 1/2 CIS of pi over 4, and 1 to the 1/2 CIS of 5 pi over 4. And raising 1 to the 1/2 is the same as what? What is 1 to the 1/2? Is just 1. 1 raised to any power is just 1. All right. We are heading to 5th period from here. I will see you all tomorrow. Have a fantastic rest of your day.